Hello everyone! Welcome to The Secrets of Calculus. Last episode, I challenged you to define a limit as the variable approaches infinity. After last episode of fixing the function party, we must now leave it and continue our mini-quest to get to the Tree of Knowledge. Oh hang on, is this video too long for you? Here's the formulas. Let me know what you did with that extra free time. The big challenge with the limit approaching infinity is that whereas you could tell if a limit existed by checking the approach from above and approach from below and making sure they equaled each other, you can't really do that if you're approaching positive or negative infinity. Sure, you can go to infinity and beyond, but you can't come back from that. And we don't have function values because infinity is technically not a number, so we can't do anything with continuity. I will dedicate an entire video to explaining why infinity is not a number, but for now, you're just going to have to trust me with that. You're just going to have to trust me that approaching infinity from above is not really a thing. So let's try the brute force method first, and then see how we can big brain the answer. To start off, it's best if we have a function with avoided values. These are values that functions either trend toward or avoid. They are basically the y equivalent of forbidden values, except they're not forbidden. For example, let's take the example of f of x equals 1 over x. From the graph, we can see that this graph doesn't want to equal 0, and a small amount of algebra will reveal why. Boom! Proof! Since there's no x that allows 0 to equal 1, this graph is incapable of touching y equals 0, so 0 is our avoided value. But we've already seen how infinity lets us divide by 0, so let's try bypassing this avoided value of 0 by letting x get really, really big. And based on this table here, we can see that as x gets larger, y gets closer to 0. When we bring the limit into this, we are given the convenient choice between having infinity be a stupidly large number, which allows us to do arithmetic stuff, or the largest possible number, which disqualifies it as a number. Again, I'll explain all this in a future video. Now, here would be a good place to say that infinity is a humongous number, which lets us say this. The limit as x approaches infinity of 1 over x equals 0. Now the cool part is that this works for any number divided by infinity, except for infinity itself. But now it begs the question, what about negative infinity? Let's see what happens. And here we can see that as x gets larger in the negative direction, y gets closer to 0, but in the negative direction. Sometimes you'll see that kind of thing notated like this, with the pluses and minuses as superscripts for the numbers. By the way, it is coincidental that the limit as x approaches positive or negative infinity is the same. It does happen a lot though. Cases where they don't equal each other usually have square roots flying around, and these equations have other problems. And now, here's how to big brain this answer. If you see an x in the denominator of a fraction, or you end up that way after canceling some x's out, you can immediately say that that part of the equation is 0. There are some things to watch out for when you're big braining this kind of way. Trigonometry. This is one of those cases where the limit as x approaches infinity might not exist because of the can only find one answer thing. Let's see what happens with this funky limit as x approaches infinity of y equals sine of x. And we're going to have a rad time with some radians. Now, even though this doesn't extend very far, we already run into some issues. Firstly, this pattern of bouncing between y equals 0, 1, and negative 1 repeats forever. So there's no number that sine of x trends towards, and the limit as x approaches infinity of sine of x does not exist. Now we've just dabbled our toes into the big braining, and this is the start of what will eventually become the flowchart of how to solve every single limit you ever find. But next episode is going to be about funky limits, like x squared over x cubed plus x to the fourth. And eventually, we're going to get away from using these tables to find limits. See you next time!